Welcome to Cherry Hill Tuition, where incredible results are achieved. In this mathematics tutorial, I will cover some of the excellent processes used by Cherry Hill to achieve the highest grades. Let's get started. You will notice that the question numbers are not consecutive and do not start from 1. This is simply because the questions refer to Cherry Hill specific material, but do not worry if you do not have access to this, as I will still cover the concepts in full. So let's get started. Question 2. Sylvia stands 25 meters from the base of a tree. The angle of elevation of the top of the tree is 17 degrees. Calculate the height of the tree, TG. Okay, so in this question, we've been given one length and one angle, and we need to work out the second length. Because this is a right angle triangle, this is a simple case of SOHCAHTOA. Okay, now let's label the triangle. So we have the hypotenuse here, which is the longest side. We've got the opposite and we've got the adjacent. We've been given the adjacent and we need to work out the opposite. So hopefully you will agree that the identity we need to use is tan. So tan of theta is equal to the opposite over the adjacent. And now we just need to plug our values in. So tan of theta, which is 17 degrees, is equal to the opposite, which is x. It's unknown, we are trying to work it out, and a over a, which is 25. And now we just need to rearrange and make x the subject. To get x on its own, we need to get rid of the divide by 25. We can do this by doing the opposite to eliminate. So we can multiply both sides by 25, leaving us with 25 tan of 17 is equal to 25x over 25. On the right-hand side, the 25s cancel out, and we are just left with 25 tan of 17 is equal to x. And now all we need to do is plug 25 tan of 17 into our calculators and see what value we get. The value you should get is 7.64. Okay, and don't forget your units. So because we're working in meters, your answer is 7.64 meters. So TG is equal to 7.64 meters. Okay, and that's your answer. Now pause this video and have a go at this question on your own to check if you get the same answer. Question 2b. Max is holding the string of a kite which is flying 30 meters above the ground. His height is 1.5 meters, the string is straight and its length is 35 meters. Calculate the angle x between the string and the ground. Okay, so we have a right angle triangle and we've been given the hypotenuse and also the opposite length. Okay, and then we have the adjacent here. Something to notice is that they have given us the length of the opposite plus this section here. We need the length of the opposite. Luckily, they have also given us the length here, which is 1.5. So to work out the length of the opposite, we just need to do 30 minus 1.5, which is 28.5. Okay, so the length of the opposite is 28.5. Now that we have two lengths and we are trying to work out an angle, and this is also a right angle triangle, we can use SOHCAHTOA. So we have the opposite and we have the hypotenuse and we are trying to work out x. So because we have the opposite and the hypotenuse, hopefully you will agree that we need to use sine. So sine of theta is equal to the opposite over the hypotenuse. And now all we need to do is plug our values in. So sine of theta, which is x, is equal to the opposite, which is 28.5, over the hypotenuse, which is 35. And now we just need to solve for x. So the only thing we need to do is get rid of this sign. And in order to get rid of this sign, we can inverse sine on both sides. On the left-hand side, the signs cancel out and we are just left with inverse sine, brackets 28.5 over 35. And this is just a simple case of plugging it into our calculators. So we should get an answer of 54.52 degrees. Okay, and that's your answer. Have a go at this on your own, again, without looking at my working out to check if you get the right answer. Question 6. The diagram shows an isosceles triangle of base 10 millimeters and height 12 millimeters. Calculate the area of the triangle. Okay, so in this question, because it's an isosceles triangle, it makes it a lot easier for us. What we can do is split this triangle in half to form a right angle triangle. So because it is an isosceles triangle, this means that this angle is equal to this angle here. This is also x. Okay, now the new bases are 5 and 5 millimeters because we have split them in half. Now we've been given the height, which is 12 millimeters. And all we need to do now is work out the area of one isosceles triangle and then double it because they are both identical. So what we can do is base times by width. So 12 multiplied by 5, which gives us an answer of 60 millimeters. This is the area of one half, and to work out the area of the total triangle, we need to multiply this by 2 to give us 120 millimeters. And that's all you need to do. So it looks tricky, but once you start really trying to analyze the question, you will notice that it is not very difficult. Okay, so let's move on. Question 6b, so we have the same isosceles triangle and we need to write down the value of tan x. Okay, so in the previous question, what we did was split this triangle in half and turn this into a right angle triangle. Now we worked out that this was 12 and this was 5. Now labeling this triangle, we have the opposite and we have the adjacent. Now, because it says write down the value of tan x, we know we need to somehow get the angle x involved. So what we can do is try and work out angle x. Because it's right angled and we have 2 lengths, we need to use SOHCAHTOA. And because we have the opposite and the adjacent, we need to use tan. So tan of theta is equal to the opposite over the adjacent. And now we just plug our values in. So tan of theta, which is x, is equal to the opposite, which is 12, over the adjacent, which is 5. So the value of tan x is 12 over 5, and that's all you need to do. The only thing left is converting this into a decimal. So 12 over 5 as a decimal is 2.4, and that's your answer. Okay, Now have a go at this question on your own without looking at the working out to check if you get the right answer. Question 7. A gardener pegs out a rope 19 meters long to form a flower bed. Calculate the size of the angle BAC. So from A to B to C, and back from C to A, all is 19 meters. We know A to B is 5 meters, B to C is 6 meters. So let's work out A to C. We can do this by doing 19 take away 5 take away 6, which gives us 8. So this is 8 meters. Now that we have all lengths and we need to work out angle BAC, which is this angle here, what we need to do is use the cosine rule. So when we have 3 lengths and we need to work out a missing angle, we need to use the cosine rule. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos A. And now we just plug our values in. So because we're working out BAC, what we can do is label this as angle A, and the opposite length is length A. This can be angle B. This is length B. This is angle C, and this is length C. And now all we need to do is plug our values in. So A squared, which is 6 squared, is equal to B squared, which is 8 squared, plus C squared, which is 5 squared, minus 2 multiplied by 8 multiplied by 5 cos of A. And now we can simplify this. So 6 squared is 36. And then we have 8 squared, which is 64, plus 5 squared, which is 25, minus 2 multiplied by 8 multiplied by 5, which is minus 80 cos of A. And now we just need to rearrange to make A the subject. So we can tidy this up by collecting like terms. So 64 plus 25, which is 89, minus 80 cos of A. Now we need cos of A to be positive, so let's add 80 cos A to both sides. Leaving us with 36 plus 80 cos of A is equal to 89. So the minus 80 cos A and the plus 80 cos A both cancel out. And then we can take 36 away from both sides, leaving us with 80 cos A, which is equal to 89 minus 36, which is 53. And the next thing we need to eliminate is the multiply by 80, so we can divide both sides by 80. So we have cos A is equal to 53 over 80. And now eliminating the cos, we can inverse cos both sides. On the left-hand side, the coses cancel out, leaving us with A. And on the right-hand side, we have inverse cos 53 over 80. And all we need to do is plug this into our calculators now. And A should give you an answer of 48.51 degrees. Okay, and that's your answer. So now again, have a go at this question on your own without looking at my working out to check if you get the right answer. Question 7b, a gardener pegs out a rope 19 meters long to form a flower bed. So part B, what we are doing is calculating the area of the triangular flower bed. Okay, so in the previous question, we did work out that this was 8 meters long, and we also worked out angle BAC to be 48.51 degrees. And now all we need to do is use the formula half AB sine C to work out the area of this triangle. So let's write that formula down. And now let's plug in our values. So because we have this angle here, we need to use this and this, the surrounding length as A and B. So multiplied by 8, multiplied by 5, multiplied by sine of 48.51. And all we need to do is plug this into our calculators. So 0.5 multiplied by 8, multiplied by 5, multiplied by sine 48.51, which should give us an answer of 14.98 meters squared. Okay, so quite straightforward. Thank you for tuning in. Remember, practice makes perfect. Never give up. I will see you in the next tutorial.